Welcome to 5.4 and 5.5 notes. It is all about the exponential. We just discovered or just finished learning about logarithms. It always seems like exponents follow right behind us. Now, if you remember when you took the derivative of e to some power, you rewrite the exponential as is and you multiply it by the derivative of the exponent. So the derivative of e to the x was e to the x. So think about what's going to happen when you integrate. When you took the derivative of an exponential that's base was not e, you had to involve that natural log of the base you did have. Okay, so be thinking about that. So be thinking about that when you are integrating. You're going to need your exponential, whatever the power is, you're going to need that derivative. So be thinking about lots and lots of u substitutions. I just put on here your exponent and your log properties just to refresh your memory. Anything about your definition, change of base formula, left that on there as a nice little review. And here we go. The integral of e to the u du, remember you're going to be looking at what the power is on your exponential, making sure that you have that derivative also so that you can use your u substitution successfully. So the integral of e to the u is e to the u, don't forget your plus c. You're going to use a u substitution anytime your power is not a 1x. So when I look at number 1 and I notice my power is a 5x, that's going to be my u substitution. My u has got to be 5x, which means my du has to be 5dx. I don't have a 5dx, so I'm going to put the 5 in there, counteract that with a 1/5, because 1/5 times 5 is 1, and you can multiply by 1 all day long. Not gonna matter. E to the u du is what we end up with. When I integrate that, I know that's going to be e to the u plus c. Remember, you can't have u in the problem. Substitute that back out. There's my final answer. So as you're looking at these, if you have just one exponential and the power is not a 1x, your power is going to be your u substitution. Looking at this, I've only got that one exponential. The power is not 1x, so the whole thing's going to be my u, which means my du is going to have to be the derivative, which is 3x squared dx. I don't have the 3 parts, so I'm going to put that in, multiplying. Then I'm going to multiply out in front so that I do have that 1. I've changed only the look. I have not changed the value. I end up with 1/3 e to the u du. Look at what a bargain that is. You've got all of that right there. All of that is du. If you're making if u stands for something bigger, then du is going to have to stand for something bigger. We are simplifying the problem so that we can integrate it with ease. We're making a substitution. The integral of e to the u is e to the u plus c. That's going to be 1/3 e to the x cubed plus c. Remember, when you integrate, you can always take the derivative of your answer to see if you get what you started with. So it's always a check that you're able to make. Now on number 3, we've got the same thing going. We've got one exponential. The power is not a 1x, it's a tangent of x. So that means tangent of x is going to be my u. My du is going to have to be the derivative of tangent, which is secant squared. And look at that, we have the exact thing. So I don't want you to immediately look at the problem and think, oh, trig functions, this is going to be hideous, oh, the horror. Because this one turned out to be really nice. We didn't have to tweak it in any way. We've got e to the u du, which means the integral is e to the u, which is tangent of x, plus c. Okay. Now on number 4, I want you to go ahead and try this problem. So pause the video, do the problem, and then turn it back on. See how well you did. Hopefully you looked up here and noticed that your power was not a 1x, so you made it the power you do have. So you let u be x squared, which is just x to the negative 2. So when I take the integral of that, that's going to be negative 2x to the negative 3 dx, which is negative 2 times x to the third dx. I have currently right now a 1 on top of here. I need a negative 2. So I'm going to put the negative 2 in here, counteract that with a negative 1/2. So what I end up with is negative 1/2 e to the u du. All that I had to put in was that 2, and all of that turned out to be du. I'm telling you, that is a real bargain. A bargain of integration. Negative 1/2 e to the u, and u was 1 over x squared plus c. So hopefully you got the right answer. If you didn't, hopefully you see where you made your mistake. Ooh, now 5 and 6. How exciting. Now on 5 and 6, we're going to have to go about this maybe a little bit differently, especially in number 5. If you have more than one exponential, then your power is probably not going to be your u substitution. And if you look at that, we've got a 1x, we've got an x to the negative 1, so that kind of makes it difficult to think about what your u substitution might be. So if you only have one exponential, if the power isn't a 1x, that's probably going to be your u substitution, that power. If you have more than one exponential, you're probably going to have to think bigger for your u substitution. Since I know that my du cannot be in the denominator, I'm going to pick the denominator for my u, the whole thing. Well, when I take the derivative of that, e to the x is e to the x. The derivative of e to the negative x is e to the negative x times negative 1. And notice that whole thing is right there in your numerator. How nice for us. So this whole thing right here, the whole kit and caboodle. I don't know where that came from, kit and caboodle. But I say it because I think it sounds cool. And you know me, I'm all about the cool. I know some of you are laughing right now because that is totally not true. Du over u. Oh, look at that. That is the natural log of the absolute value of u. So now that we've covered u substitution, we've covered all powers, we've got logarithms, we've got exponentials, we could literally just about have anything. Don't forget to substitute that u back out of there. We want no part of u. I know that sounds mean, but we don't want u in our answer. 6 is a little bit different. Even though I have more than one exponential, I'm not going to use the same method I did in number 5 because I can literally divide these. When I look at this, I can take e to the 2x divided by e to the 1x. Remember, when you divide, you subtract your exponent. So 2x minus 1x is 1x. That's going to be plus 2 because the e to the x is cancel. And then I've got plus 1e to the negative x. Now this is what I call a baby u substitution. The first two terms are fine, they're ready to go, there's no problem. The problem comes from this term right here, this e to the negative x dx. I do need to do a little u substitution, and I call it a baby u substitution because in the future you're probably going to get good enough that when you see e to the negative x, e to the 2x, e to the 7x, you're going to immediately know how to integrate that without using a u substitution. But right now, we kind of need that extra help until we can get the swing of things. My power is going to be my u, so du is going to have to be negative dx. So I'm going to slip that negative in and counteract that with a negative 1 on the outside. Now I have negative 1, or you can leave the 1 off, e to the u du. Don't forget to bring down the rest of your integral or you are going to be sad when you get your test back. So the integral of e to the x is e to the x. The integral of 2 is 2x. The integral of negative e to the u is negative e to the u. And don't forget what u was. I love the u substitution. It makes me sound like I'm grammatically incorrect, which I am a lot of times, but not as much as I am saying the u substitution. So u is negative x. Substitute that out. Now we have all kinds of exponentials. Doesn't matter what the base is, but if the base is not e, you're going to counteract that as such. When you integrate, you're going to have 1 over the natural log of the base you do have times the exponential as is plus c. So when I'm looking here, this is again one of our baby u substitutions. You have 5 to the negative x. You're going to have to do your u is negative x. So your du is going to be negative 1 dx. I don't have that negative inside, so I'm going to put the negative 1 on the inside, counteract that with its reciprocal. And remember, the reciprocal of negative 1 is negative 1. So I get negative 1 times the integral 5 to the u du. When I integrate that, that's going to be negative 1 times 1 over the natural log of 5 times 5 to the u plus c. Don't forget to substitute that out. So I've got negative 1 over natural log of 5 times 5 to the negative x. Almost wrote a dx there, plus c. Now, because of the negative exponent, if you want to, you can go ahead and put it in the denominator. So that's going to be negative 1 over 5 to the x times the natural log of 5 plus c. That's going to be my final answer. Well, he took up a lot of room, so hopefully I can get this all in there. I bet I can. When I'm looking at this, I've got 7 to a power. So the same rules for other bases we're going to use for the base e. If you've only got one exponential, once again, your power is probably going to be your u. So that would be 3 minus x to the second power. So du is going to be, bring that power down, a chain rule, how about that, to the 1 power times the derivative of what's inside. Looks like we have that 3 minus x. The only thing I'm missing is that 2 and that negative 1, so times negative 2. I'm going to counteract that with a negative 1/2. When I simplify this whole problem, I'm going to have negative 1/2 times the integral 7 to the u du. I mean, when you think about the u substitution, it is phenomenal. All of this is incorporated into the du. I'm amazed. When I integrate that, I'm going to have negative 1/2 times 1 over the natural log of 7 times 7 to the u plus c. And then make your substitutions back. You've got negative 1 times 7. And if you want to separate those, give those a little bit of distance, that's fine. 7 to the 3 minus x. We'll stick right there. Come here. Okay, plus c. Now, it would not be wrong to put negative 7, 3 minus x squared. It's the same thing. Just be careful. Don't put in parentheses around that negative and that 7 because then you have changed the problem. So either one of these is going to work perfectly for your answer. It just depends on what you think looks better or what you think looks less confusing. Ooh, I normally say box in your answers, but ooh, I'm just blobbing them in now. So either one of those answers in the green blob will work. Okay. Now number 3 here, once again, do not be concerned. You've got one exponential, so you know that exponent is going to be your u. So du is going to be cosine of x dx. Notice, see, I didn't make a hiccup this time, unlike video 5.2. We are taking the derivative, so remember the derivative of sine is just regular cosine. This becomes 2 to the u du. No problems there. 1 over the natural log of the base we do have times your exponential as is. And then if you want to simplify that, write it out. Remember, you have no choice but to substitute out your u. But if you just wanted to write 1 over the natural log of 2 times 2 to the sine of x, that would be fine. You don't have to write them on top of each other, but I think it just looks a little bit nicer. Okay. Now number 4, that's just kind of being silly because I'm wanting you to think. A lot of times people will just look at this and go, ooh, 2 exponentials, away we go. Now, are these exponentials? Hopefully you've answered the computer, no, they are not exponentials. Exponentials have a variable in their power. This is just 3 cubed. That's just 27. Minus 25. Those aren't exponentials. They've got exponents. They're just numbers. So you're actually integrating the 2. So when I integrate 2, if we want to do some old-fashioned first fundamental theorem of calculus, the integral is 2x. You put the 0 in first and then the negative 2. So 2 times 0 minus 2 times negative 2. That gives us a positive 4. So be careful. Exponentials have variables in their power. Alrighty, I'll see you tomorrow.